Natural gas is mostly made up of methane, which is hard to handle because it's a gas at room temperature. But what if we could turn that methane into something more useful, like hydrogen? It turns out we can do that by burning natural gas in a controlled way. When we burn stuff, we usually think about the substance undergoing a process known as complete combustion. In complete combustion, a fuel like methane reacts with oxygen, usually from the air, to create new products. For example, burning methane in oxygen creates carbon dioxide and water. If we collect all the products of this reaction, we find that their masses add up to more than the original amount of methane plus oxygen that went in. And that makes sense because burning methane forms new bonds between atoms, releasing energy that shows up as heat and light. So, complete combustion is basically the opposite of building up molecules from smaller pieces. Instead, it's breaking down molecules into simpler parts. But what if we did the opposite? What if we took those carbon dioxide and water molecules and built them back up into methane and oxygen? Well, it turns out that we can, by combining carbon dioxide and water in just the right ways, we can synthesize methane and release oxygen as a byproduct. And since methane is a fuel, we could use it to make more hydrogen. That would be kind of cool. But it's also kind of tricky because we'd have to synthesize methane from scratch. But what if instead of starting with carbon dioxide and water, we started with something a bit closer to methane, like natural gas? Could we build up hydrogen from natural gas without going through the trouble of making methane first? It turns out we can. And there's more than one way to do it. We talked about one way to make hydrogen from natural gas in our last episode, which involves turning the natural gas into a bunch of smaller molecules like hydrogen, carbon monoxide, and carbon dioxide. That process is called steam methane reforming. But in today's episode, we're going to talk about another way to turn natural gas into hydrogen called partial oxidation. So let us see how partial oxidation works and what its pros and cons are compared to steam methane reforming. Another way to turn natural gas into hydrogen is through a method called partial oxidation. This process is a little different from complete combustion, which is what happens when you burn a fuel completely with plenty of oxygen. In partial oxidation, a limited amount of oxygen is used just enough to partially react with the methane and other hydrocarbons in natural gas, because there isn't enough oxygen to fully burn everything. The main products that come out are hydrogen and carbon monoxide rather than carbon dioxide and water. When air is used instead of pure oxygen, nitrogen ends up in the mix too. Some other substances might also be produced in small amounts, like carbon dioxide, hydrogen sulfide H's, and carbonyl sulfide Cos, along with some leftover, unreacted hydrocarbons. But the key goal of this process is to make syngas a gas mixture mostly made up of hydrogen and carbon monoxide. The chemical reaction for partial oxidation of methane is straightforward. One methane molecule reacts with half a molecule of oxygen to create one carbon monoxide molecule and two hydrogen molecules. This reaction also gives off heat, which is useful because it helps power the process. If more oxygen is added, then you get full combustion resulting in carbon dioxide and water instead of hydrogen. That's not what we want for hydrogen production, so careful control of the oxygen level is important. There's another version of this process where steam is used instead of oxygen. In that case, the methane reacts with water vapor to produce carbon monoxide and more hydrogen. This version produces a higher ratio of hydrogen to carbon monoxide, which can be useful depending on the end use of the hydrogen. After the initial reaction, the carbon monoxide that S formed can go through a second reaction with more steam in what S called the water gas shift reaction. This helps produce even more hydrogen, although it also generates some carbon dioxide. If needed, a carbon capture system can be added to trap that CO before it is released into the atmosphere. Partial oxidation systems are usually very hot, running at temperatures between 1,300 degrees Celsius and 1,500 degrees Celsius and operate at fairly high pressures, usually between 3 and 8 megapascals. This version of the process doesn't require a catalyst, which simplifies things, but it uses a lot of heat. However, there's also a version of partial oxidation that does use a catalyst known as catalytic partial oxidation, or CPOX. When a catalyst is used, the temperature can be much lower, around 700 degrees Celsius to 1,000 degrees Celsius. This saves energy, but there's a trade-off. These systems are more sensitive and need to be carefully managed to avoid problems like carbon buildup, which can block the reaction. Common catalysts used in CPOX include those made from nickel or rhodium. There are pros and cons to each of these two methods for using natural gas to make hydrogen. Steam methane reforming has an easier time handling impurities that might be present in the natural gas. But it needs high temperatures and pressures, and it produces a lot of carbon dioxide. On the other hand, partial oxidation is simpler overall and doesn't produce any carbon dioxide, but it's harder to deal with impurities. Which method is better depends on the specific situation and the quality of the natural gas that's available. So, scientists and engineers keep working on improving both processes. Ultimately, developing methods to make hydrogen from natural gas could help reduce our reliance on fossil fuels in a few ways. For one, hydrogen made from natural gas can be used as a clean, burning fuel in things like fuel cells, which could help cut pollution. Hydrogen can also be combined with carbon dioxide to make methanol, which can serve as a clean, burning fuel or be turned into other useful things like plastics or chemicals. Finally, hydrogen made from natural gas could be used as a way to store energy. In the process of making hydrogen, you store energy in chemical bonds. Then later, that energy can be released when the hydrogen is burned or used in some other way. While hydrogen isn't always the best solution, it might be helpful in certain situations until we can transition to a future powered by renewables. The future is renewable energy, but we're not there yet. And while we work to get there will still be a need for efficient, reliable, less polluting ways to generate electricity from fossil fuels. Enter the Aggie Thermoselect gas turbine. This device uses cutting-edge technology to improve the efficiency of natural gas-fired power plants. It uses a unique recuperative cycle to recapture waste heat and direct it to where it's needed most, resulting in an overall thermal efficiency of around 50%. This is around twice that of conventional gas turbines. The thermal energy system was developed over several years at the Max Planck Institute for Dynamics and Control of Complex Systems in Germany. It was designed to fit into a shipping container to make it easy to transport and set up anywhere it's needed. This design also means that the entire system can be powered by a single person. Natural gas-fired power plants run at about 35% efficiency, meaning they waste 65% of the energy they consume. This new system cuts those numbers in half, wasting less fuel and producing fewer pollutants. And it can be used to generate power anywhere there's a need, whether that's a town recovering from a storm or a community that needs a backup power source. Not only does this solve the problem of how to efficiently run natural gas turbines, but it also offers a clean, efficient way to run off. If you liked learning about partial oxidation, then you'll love Brilliant's course on chemical reactions. You can learn about reversible and irreversible reactions, chemical equilibrium, and more. And if you don't like it, you can always get a refund. Just make sure to use our link. Thanks for watching.